Hello friends, welcome to YouTube channel CrackGate Online. So this is video 1.2 of the Bund topic. So in the last video we discussed about the basics of Bund, what is the Bund and what is their advantage, disadvantage, their functions. So now in this video I will discuss about type of Bund. So there are mainly four type of Bund, or there are 4-5 you can classify. So basically there is contour Bund, so you have heard the name contour Bund. Then there is the graded Bund, another is there is the side Bund. Okay, there is side Bund, and one more is the lateral Bund, and there is one more type that is called the circular Bund. Okay, so basically we divide in these classes: contour, graded, side Bund, lateral Bund, and the circular Bund. So I will discuss about all these bunds and what is the design criteria for the bund. So let's begin. So here you can see two major type of bund is the contour bund and the graded bund. So what do you understand by this contour? So the definition of contour is the points having equal elevation. So from that definition only this word is derived, and this type of bund is known for that they are constructed on the same elevation. So sometimes you will see the path change in path of this bund, so that change in path show the equal elevation points. That is why they are known as the contour bunds. And other is the graded bund. Graded bund means the basic difference is the contour bund is made for the storage of water, okay, while the graded bunds are constructed for the disposal of excess runoff. Okay, so the basic difference between these two bunds is these are for storage and this is for the disposal. Okay, so the same thing is written here, you can see. So as I told you in previous video also, so this is your bund and this is how. So here you can assume you will have another bund, so and this will be the slope, so it will be like this. Okay, so this is the storage of water in between these two bund. This is bund number 1 and this is bund number 2. Okay, so there will be certain differences as contour bund is used not more than 700 mm rainfall. So contour bund is always used in an area where annual rainfall is less than 700 mm, while graded bund can be used in some area where rainfall is greater than 700 mm, while the land slope for contour is not more than 6%. Basically it is 2 to 6%, while graded bund can be made where land slope is up to 8%, 2 to 8%, but not more than the 8%. Okay, so what do you understand by this land slope? Land slope is defined as, suppose this is the land, and if I say 2% means suppose this point is 1 and this point is 2, and the projected distance between these two is suppose 100. Okay, so the elevation difference between these 2 points, this point, that will be 2. Okay, so this is for 2% slope. Suppose the elevation difference between this point and this point, this vertical difference, if it is 5, then and for same projected distance 100, then your slope will be 5%. So this is the meaning of slope. So that is nothing but a drop in height. Okay, so from this point your height is dropping how much amount over the distance of 100. So that is known as the slope. So when you heard this slope, so immediately this definition, this concept should come into your mind. So for this length, this is the slope. If you will call this as slope, okay, so if it is 100, then the elevation difference between this point and this point, okay, considering the distance, horizontal distance is 100, and if slope is 5%, then this distance will be 5. Okay, so here you will store water like this. So let me tell you whatever I said. So this is the adaptability where you will use contour bund and where you will use the graded bund. So the land slope should be, here you can say 2 to 6% or 8%. So basically uniformly you can remember it is 8%, but rainfall should be, here it is less than 700, and the soil should be light and shallow so that maximum amount of surface runoff can be absorbed into the soil. Okay, but here you see rainfall is less than 700 mm and you are using the graded bund. Why? Because see, the type of soil is heavy clay soil, and if type is heavy clay means water infiltration is not taking place. Even though rainfall is less, but your infiltration is not taking place, means you have to discharge the extra amount of water, because water is uh, holding onto the ground surface, because clay soil cannot infiltrate more water as compared to your shallow sandy soil. Sandy soil has more infiltration capacity. So even though rainfall is less, you have to use the graded bund. And if your soil is sandy soil, then even in so the rainfall amount is greater than 700, but soil is light, so in this condition it can absorb the amount of the optimum amount of the water. So here you can use the graded bund. So basically you have to remember, graded bund, the function is to dispose the amount of water, while in contour bund you have to retain the amount of water. So here I think this table is clear. So you have to understand the concept, and based on that you have to remember. So here I told you earlier, it is what is side bund and lateral bund. So suppose, so this is the picture I have shown you earlier. So this is the land slope and this is the contour. So side slope is nothing but side bund is nothing but if you are creating bund over here and here on the side of the contour bund, then it is called the side bund. And if you need, you can connect this side bund, and if you are connecting this all this side bund, it will become the lateral bund. So here you see what I told, it is the land slope. Okay, and where you are constructing this bund, along the slope. Okay, it is not across the slope, but bund, actual bund is constructed across the slope. Okay, so you have to remember this key point, it is along the slope. Here you can see it is along the slope, and it is also here along the slope. So this is the basic difference. So same thing I told you earlier. So here you can see, if you are constructing side bunds here this direction, and if you join all this, it will become lateral. So some other bund, it is semicircular bund. So here you can see semicircular bund is used for planting material. So if you are suppose this is the land and here you are making bund, so here you can use your planting material. So this is a type of bund mainly used for the plantation work, not such a big deal. Okay, you can read it here. So the last topic for this presentation, I would like to say what design criteria you will consider while designing a bund. Okay, so as I told you, bund is used here. I am not talking about the contour bund or the graded bund. Okay, so I am talking bund in general. So as I told, that bund is used to store water as well as to dispose the surface runoff. So suppose this is your two bund and this is the land slope. So you have to consider the cropping pattern, what crop you want to take in that particular area. Based on that only you will decide what is the amount of water you want to keep in between the bunds. So here you are trying to save the water here in between two bunds. So until unless you don't know about your crop, how you will decide the amount of water? Suppose you are taking the paddy crop, then you need the higher amount of water. Suppose you are taking the some other crop which requires less water, then you need very less amount of water. So based on that you will decide the where. So suppose this is the length of bund. Okay, so this is the length of bund. So here in entire length this water is stored. So based on the quantity of water you retain here, you will provide here some where. So it will be also along the length. So water will go from this side to that side of the bund. So here will be land slope and here other bund will be there. Okay, so excess amount of water you can discharge from one side of bund to other side of bund. So this is the first criteria, how much water you want to keep it here. What will be the second criteria? You can think, second criteria will be material in consideration, means economy of construction, whether you want to use sand or whether you want to use soil or stone. So economical consideration will be the second point. What other design parameter you can think of? Other design parameter will be, what will be the size of this bund. So for size of the bund we will discuss in other upcoming videos, but for now you consider, if you want to determine the size of the bund, you have to consider what is the depth of water, means how much amount of water, the height of water you want to retain inside the bund. That will decide your size of bund. Suppose you want to store water up to this height, so okay, so definitely your size of bund, so this base width also it will increase like this. And if the depth is increasing, then your total base width will also increase. So one thumb rule is there, that this is known as the seepage line. Okay, this point line is known as the seepage line, and the seepage line must pass through to the toe of the bund. So this is one design criteria. So more is the height of the water retention, more will be your size of the bund, and more is the size of the bund, again it is constructing your economy of construction. So one point is related with other. And what is the other criteria? Other criteria is non-erosive velocity. What is this non-erosive velocity? As I told you, suppose this is your bund, it is just representative diagram, and here you are retaining the water. Okay, so suppose if rainfall is happening and the distance between two bund is so large that your runoff is getting sufficient time to travel over this land, and it is also able to cause the erosion. Okay, then what is the meaning of this construction of this bund? As I told you, the one of the function of this bund is also to check the erosion, and if this distance is so much that it is causing the erosion, then there is no point of this design, then it is poor design. Okay, so you have to consider this non-erosive velocity. The distance between these two bund should be such that it should store the optimum quantity of water without any erosion. So I think all you know that what is the formula for erosive velocity, that is Manning's equation, 1 by n r to the power 2 by 3 and s to the power how much, 1 by 2 in meter per second. So tell me by thinking, what will be the value of V for sandy soil? It will be higher or it will be lower? So definitely it will be lower. Because why? Because sand soil has very low cohesion. Okay, so if cohesion is low, then a small velocity of water can also detach this soil particle, while in clay soil your cohesion between the two particles is high, so you need higher velocity. Okay, if your V will be higher as compared to sandy soil, then only this soil particle will be detached and erosion will control. So here you can see for sandy soil it is 0.5, but for erosion resistant soil, or basically you understand as clay soil, it will be lower than or higher than 0.5. Definitely it will be higher than 0.5. Okay, so in objective type question you should have this thing in your mind, which will be higher, which will be lesser, based on conceptual clarity. So from here you can calculate your erosive velocity from the Manning equation. So you have to consider amount of water storage in between this. You have to consider that this water should not cause the erosion. You should consider the cost of construction, and you should consider the size of this bund. The size of this bund should not be too big. So this is a design criteria for bund in general, but in case of contour bund, graded bund, you have to consider some other parameters which I will discuss in the upcoming videos. Okay, so this is for this video. So till now you got what is bund, what are the types of bund, and what is the design criteria for bund. So you have to deal with only two types of bund. One is the contour bund and other is the graded bund. So from the next video I will discuss contour bunds, where we will discuss vertical interval, horizontal interval, all the technical details and related numericals of previous year GATE.